Welcome back to another podcast. Our topic of today is site assessment for PV off-grid systems. And we already talked about sizing and the relevance of knowing what is required and what the customer wants to power with the solar system. So let's have a closer look at how to find out what the customer requires. Let's talk about site assessment and site inspections. And for this topic, I have invited Dave Mathews. He is a solar installer and Green Solar Academy trainer from Zimbabwe, working for his own company, Sunergy. But Dave, please introduce yourself with a few words.
I'm Dave Mathews. I've lived in Zimbabwe, always have lived in Zimbabwe. And about 10 years ago, I decided that I needed a new challenge in life. So started in the solar business and the solar industry. I've always had a lifetime of interest in solar because of my particular lifestyle, which has largely been rural based. I'm a great lover of being in the bush. And obviously solar is one of the best alternatives to any other means of power wherever you are in this wonderful country of ours. So yeah, that's me. And we've been involved with solar for about 10 years. I think we've been involved with the Green Academy for at least 5 of those years, or even 6. So yeah, and I haven't had a bad, poor, horrible day at all since that time. So it was the right decision.
Thanks, Dave. Okay. So for how long have you been installing solar systems, and what kind of systems?
Yeah, principally the market in this country is for off-grid. We have had quite a few difficulties with the national grid power supply. Not only does it not cover the whole country, we're covering around ZESO, which is our national utility supplier, supplies about 60% of the country at the moment, between 50 and 60%. And so there is vast areas of the country that have no access to power whatsoever. And also our power supply has been fairly irregular, even with what has been able to be supplied by the grid utility supplier. So generally, most of our business here is off-grid, and we expect that to remain going forward for some considerable number of years. That's the grid utility, is aiming to introduce the various techniques that are operating elsewhere in the world, such as grid-tied, feed-in tariffs and all the rest of it, but they're still way behind in actually doing the actual implementation of those systems. For example, you can look up their website for feed-in tariffs, and they've got a whole series of documents which don't appear on their website yet. So things are a bit confusing, but it will come right with time, of that I am sure.
Okay. So you've been dealing a lot with off-grid systems now.
Purely off-grid, okay? If there is a ZESA supply, or if there's a utility supply, basically the customer preference is to utilize solar wherever possible.
Okay, that's good. Perfect conditions for us, because we are also dealing with off-grid systems in this course and in this podcast. Let's get into the topic. I think to understand what we are talking about and what is essential for a site visit, we must look at the clients first. It's all about understanding the client's needs. So who are typical clients for off-grid PV systems?
Basically, it covers the whole range. We start off with people who are just wanting to start off with putting in some sort of solar supply to their houses. And then, and we've done a vast number of those, too many to mention. Varying sizes, mainly 3 kilowatt for the smaller systems, the flats, the garden flats, that sort of stuff, or even proper houses, okay, which do not have the access to borehole swimming pools and things like that. Okay, and then we go up from there, but the main demand is in the 5 kilowatt system, which is what we see the most demand for. And they're becoming very prevalent within Zimbabwe, and that is most of where our business is. But we also specialize in bigger systems than that. We have supplied hospitals, old people's homes and all the rest of it, and those go up to 5, 30, 35 kilowatt systems. So that's where we are at the moment. So it covers really the whole range of off-grid requirements. Basically, our clients usually approach us through word of mouth. We have a reputation for installing quality product installations. We believe that forging a close relationship with our customers, not only during the installation phase, but in the follow-ups thereafter, are valuable for both them and for ourselves. And that's where we sit at the moment. But generally, it's all preempted either by a visit to our offices or a telephone call. And from that, usually what we ask for as a first step is if they do have access to power, let's have a copy of the utility bill. It only helps to a limited extent, particularly when power is quite irregular, but it gives us a start in the right place. We also try and get them to send us their position so we can get a Google map of their location. We find that's a very useful first stage, so we know basically what we're looking at, particularly size of property that we're on, what kind of structures are on it, the level of shading that we have to look at, and all the rest of it. So it gives us a bit of an input as to where to go when we start this thing. And generally, wherever we are in the world, a Google map is available, and that's what we like as a first step in any of these installations. But obviously, the main thrust is when we do the site visit, and that's what we've got to make sure that we're well prepared for. It's the part I like best, because solar is not a precise science. It's got principles that we have to follow, but generally it's a fairly nice interpretation of what the standard test conditions are and how you apply them to reality, which is a lot of fun. And we particularly had a lot of fun with our offices here in Harare, which are on solar. It wasn't designed, the system that we were initially looking at wasn't designed to operate the full office block. It was just designed to look after us as Sunergy, but we do have other participants or other occupiers in the rest of the offices. And with everything that's happened, we now have our whole system running off solar. It's an off-grid system completely, and we've got it such that we're able to operate very efficiently and very effectively, and we don't know whether we've got ZESA or not, but we have power all the time.
That brings us to the purpose of a site visit. So you said you did not design the system for the office, which is kind of not the normal way to go. You're lucky that it worked out. What role does the site visit play in the design and sizing of an off-grid system normally?
Oh, it's the most critical. Your preparation, it's like with anything. If your preparation is right, then you're fairly confident that the system and what happens downstream will go right. So for us, fundamentally, the site visit is the most key part of the whole process. And it can be split into two phases. Firstly, make sure that before you go on the site visit, make sure you're armed with as much as you've got. And that goes down to make sure you have sufficient paper, you have a pen, you have a tape measure, because measurement is fairly important in these things, particularly when you're on site and you're looking to where you may house the inverter and the battery pack and all the rest of it. You also need to make sure that you've got some of the tools of the trade. Make sure that you have an instrument tester. Make sure that you have all the basic things that you require to be able to do a site visit. There is a list which we follow of the basic equipment that we want. You need to be in a position where you'll be able to look at the inclination of the roof. You need to be able to have even a clipboard. I've been on a site visit where I've forgotten the bloody clipboard, can you believe? And that is a bit of a problem from time to time. So yes, make sure that you're as prepared as you can be. And since I left my clipboard, I make sure that I have a separate bag with everything I need in it. Make sure you're prepared for your visit. That's the main thing. Make sure that your customer is prepared to receive you and is prepared to devote sufficient time to enable you to go through everything that you need to go through with them. It is not a 5-minute job. It's not a half an hour job. It's a good morning or afternoon job if you want to get it done correctly.
How much do the clients know when you come? Like, do you start explaining the concept of solar PV to them, or do they already know and you can get to the technical things, measuring the roof and stuff right away?
What our sort of general stab at it is that we try and explain as much as possible over the phone as to what we're actually going to be looking at. A lot of our clients come in with very high expectations of what the solar system can do. and they'll come in and simply say, well, their mate has been talking about a 5 kilowatt system, so we want a 5 kilowatt system. So we try and explain to them before we visit as much as we can as to what they should expect when we get there. And then obviously our approach is refined when we get on site. And sometimes it becomes quite obvious. Sometimes it becomes less obvious when you actually get onto site. So yeah, that's what we try and do. We try and prepare the customer as much as possible before we get there.
And then while on site, obviously you're collecting the data, measuring, seeing what is there, but are you already planning the system in your head, or does that come later?
No, I would suggest that when you've got the Google map in front of you, you've got a fairly good idea of where you're going to be at before you even go. That's why we like the Google map. We like it a lot, okay, because it answers a lot of questions for you when you get onto site. But obviously, the really critical part of the whole thing is the load assessment. Before you start even looking at panels, you might have an idea of where it is. You will go armed with the data sheets as part of your package. Okay, but that might be thrown out the window by the time you get there because of the circumstances of what the customer actually needs. And that's largely determined by the load assessment. And the load assessment is critical. If you make a mistake in the load assessment, or the customer's not being honest with you, or believes that he wants to leave things out, which subsequently he later puts in, those are all cause for failures going forward. So the load assessment is critical.
Can you talk us through how you are doing a load assessment? What questions do you ask? What procedures do you follow to get the true information?
We go through and suggest what kind of devices does the person want to operate on the system. That's important. If they want to operate stoves and air conditioners and geysers, you're really looking at a different solution. You've also got to ask him what kind of budget he's got. What is his budget? How is he going to fund it? Because the budget will determine what the size of the system will be. Although we will have advised him prior to the site visit to say, if you're looking at a 5 kilowatt system, this is what you're looking at approximately. That's how we approach that. When we go there, we want to have details of the devices, the number of hours they operate, they expect those devices to operate for. We certainly need to know the size of the device, okay? And from that, we can actually then, once we've got all that written down, an indication of approximately what load that they're looking at operating through the system, we can then advise them as to what they can do to minimize that requirement. We've just done one late last year, for an NGO, and believe it or not, we got the business purely because of the discussion we had with the client, which showed that they didn't need one of those servers. They had a server there, which was consuming a kilowatt of power, which was literally looking after their emails. So we said, rather take that out, put it somewhere where it's more useful, and just use a desktop, and you'll be able to do it. And that saved themselves, that put them from being a very big system, which everybody else had quoted on, to a system which was far more affordable for them. So that only came out of the load assessment and the load analysis we did with the customer. And since that time, they haven't looked back. They're there. We phone them every now and then, say, how are things going? They're quite happy. So that's the kind of importance that you get out of the load assessment.
How do you plan the visit? Is it that you tell the client, okay, I need to see everything, and then you ask, okay, what's behind this door, what's behind that door? So you really inspect everything, or how do you get to see the secret servers and things?
The first thing that we do is we actually take a general walk around the whole of the site that we're looking at. That must be your first phase. And you're noting, and you should be drawing down on your piece of paper with your clipboard, you should be noting down where you can possibly mount the roof structure, which is the PV generator, which is important, with how the roof structure is looking generally. What roofs can we use? Can we mount it on the roof, which 95% of the cases we can, right? Or do we have to go for an off-roof ground-mounted structure, something of that nature, which we haven't done yet, although there are a couple of ones that we're looking at which may require that. but generally have a good look around, find out where the switchboard is, the DB, because that's going to now start to determine where you're going to be putting your inverter and your batteries and that kind of stuff. So we have a general look around. One of the other things to make sure of is that the access to the DB is convenient and easy. We did another installation last year where we wouldn't touch that distribution board with anything surrounding us, even with an army of electricians. It was bad. So what we did is we mounted it off the DB. We put the whole thing in a separate area and just simply took the wiring off that we required off the main incoming ZESA board. So yeah, there's ways that and means of doing that. But firstly, you start off with orientating yourself to what the customer's premises are all about. Then we look at the load analysis. And the load analysis is, by that time, we've got a pretty good idea of what everywhere contains, what's on the site. And then from there, we start to drill down into the detail of what the size of each appliance is that they wish to operate. And at the end of the day, you can't give them a decision on the turn. We can give them a broad outline, but take all that data away and then go and prepare it properly before you submit back a document which they must sign off on. The load assessment and everything else must be signed off on. Otherwise, you're going to have problems down the line if the system does not work as planned.
Okay, so that's for safety for you as an installer, that the client doesn't come back and tell you, I wanted this and that, and now the system can't provide that, so that you can show them the form and tell them, okay, at the time you told me you only want to connect this and that, and not all the other things that are too big for the system now.
Absolutely, that's what we do. We can size up a bigger system, but we've got to point out to the people or to the client that basically, like with the NGO we did, if you do it this way, you can save yourself money, and you can still have a system that's doing as well as you wanted it to do beforehand. So yeah, that's the kind of thing. But it's very much of a give and take. You've got to have the patience of Job, because sometimes you're talking to people that believe they know everything before you even got to it. And it's something that you've got to work through. But you can do that, and you've got to use all the psychological weapons at your disposal. And you knowing me, Vivian, patience, tolerance, and reasonableness are not my best middle names, but it's a lot of fun. Yeah, it's a lot of fun.
Yeah, you see many different households and applications of solar systems. That must be pretty cool.
Yeah, it is. It's absolutely amazing. And the way that you come up with your solution is very different in just about every single case. There's not one system that I can say is the same. They're all different, and that's what makes the game so exciting.
True, yeah. And the site assessment necessary, to kind of inspect the site and then choose the right solution. But
and that is why the assessment is so critical.
Yeah, true. To get back to the structure of the assessment, so basically you're talking through all the steps of the system design and check the conditions on site. So you start with the load assessment, you check the room for the battery, the room for the inverter, cableways. So you're kind of preparing, going through really the different steps of the design and then checking the local conditions for that.
Once you've got to that, then obviously the PV generator is the next big issue that one has got to look at, because you've now got an approximate load assessment of what the system's going to take. Now you've got to be able to do some fairly accurate assessments of how many panels are going to be required, how they're going to be mounted, whether they can be mounted. You may have to look at different options and all that sort of thing. That's the next most critical thing.
So on site, you should already, after you did the load assessment, are you saying that you should already check how many panels approximately would that be?
Absolutely.
And then, because it does make a difference if it's 5 panels or if it's 20 panels.
Yeah.
And then check if there's roof space available for the number of panels that's needed.
Absolutely. It's that is important. And listen, you're not aiming to say to the client right there and then, this is the number of panels and that's where we're going to put them. Okay, you'll be turning around to your client and saying, this is the number of panels we expect you would need. In the meantime, you have to have details of the roof structure. You've got to measure it up and make sure it's there. You've got to have an understanding of what the roof structure is, what you must get into the roof, all right, and look at the state of the rafters and all the rest of it. That you can all do as part of your site assessment, and that is also very much required. In certain instances, like at Kuranda, which you may remember, we actually, because it was such a big system, we actually had to get an engineer's sign-off on the fact that the roof could take the number of panels that were required. I think it was, what was it? I can't remember, 57 or something like that per side, I think. So, yeah, it was quite a big number. So these are the sort of things that you need to do. So, yeah, but you have all your measurements with you. And as I was about to say, there's another system that we put in where we actually mounted this panels east, west, and north. And because there was insufficient space on any single, there was no real north-facing roof that we could use except under a lot of shading. And the guy was not interested in chopping down any of his trees. And it's worked wonderfully. In fact, we prefer east-west arrays to a north-facing array in our part of the world. Obviously, up in Ethiopia and those places, it'll be south-facing, won't it?
It will be, but it's quite close to the equator, so
Yeah.
I think east-west is also a good option.
East-west is great.
Yeah, that's east you get the sun in the morning, and west you get the sun in the afternoon. And for like people who are at work, it's nice because during noon you're at work, so you're not at home. But in the morning and in the afternoon is when you need the sun probably, or the electricity.
Yeah, and also the generation is much better. You're starting to get PV into your system much earlier in the morning and much later in the evening. Yeah, we actually prefer them.
Makes sense. Like that's part of the site assessment, hey? Talking to the users, asking when are you home, what are your like usage patterns, to find out if they need a lot of power or if they need constant power during the day, and then east-west would be a really good option.
What we also have done in certain instances is at the site visit, we ask if we can actually connect up one of our measuring devices to their DB. And let's look at what their energy demand pattern's all about. That we found is fairly useful in certain instances as well. But funnily enough, not much except at Kuranda. Kuranda was very different. But at a household, it's very much the traditional bell curve we're used to seeing in terms of how the usage goes.
But that, of course, only works if the people already have either a connection to the public grid or a generator or anything. How is it for off-grid systems? When you're in rural areas, for example, where people have no power at all, and the solar PV system would be the first power source they get, how would the site survey be different in those cases?
Well, the principles remain the same, but what you will find, particularly in the rural areas, is the budget availability is very, very, very different. And what we are finding there is that generally, and also you can't go too complicated in some of the more remote rural areas because there's not the technical expertise to be able to do it. And what we find there is a DC system is in our mind, much better to explain, much easier to explain, and much easier to install. Okay, and the maintenance is a lot better. So again, it's asking a fairly different question to us, but we would certainly recommend DC in some of the deeply rural areas that we're talking about, where the same thing applies. You've got to know where the panels are going to go and how they're going to go. You have to know what the load assessment is. But generally, the people in the rural areas, which are traditionally farmers, small-scale farmers, okay, grocery owners and all the rest of it, don't have that ready cash available to indulge in anything too expensive or too elaborate to start with. So yeah, we're talking about a different route there. So I don't know whether that needs to be covered here, but certainly a small DC system is very much the way to go. And what we are finding is that these smaller systems certainly will be able to do poultry. They can do lighting. They can do refrigeration. Those are the things that we sort of more concentrate on then. And also being DC small scale, we can build it up in stages as the people's income demand. So yeah, it's a very different area for us. Schools and clinics would be more the traditional 5 kilowatt system or whatever the case may be. depending on what they are. But generally, we are saying DC is the cheapest and best and most simple way to go in the rural areas, and it's very easy for a person in the rural area to grasp those concepts.
So DC, just to explain, DC, like solar modules, a charge controller and a battery, and then the loads connected to the charge controller ideally, or I don't know, sometimes directly to the battery, but rather charge controller.
That's right. And generally maybe even a small inverter off the battery to be able to run TVs and things like that.
Considering the local conditions is important, interviewing the people, getting an impression of their way of life, how they use electricity or how they will use the electricity. How do you make sure that you don't forget anything while out there?
Well, I don't think we're cheating, but there's a very, very good form that's used by DGS, which covers every man and his dog. Okay, and I will not go out without one of those DGS forms, because just a quick tick through, like a checklist, you can make sure that you've got everything covered. That DGS list is very good. It's exhaustive, and those bits that you don't need, just leave out. But generally, you can cover everything in that DGS checklist. It's the way that we would recommend that you go.
It's in your handouts, guys, just in case when you're looking for it. What do you do when you forget something? Or rather, I found the few times I was on site and participating in site assessments where I was involved in a project planning, it was always, you couldn't take enough pictures of things, and you always afterwards, I always felt like, oh no, that piece of information I should have noted down. They maybe said that, but I didn't write it down. So what is your experience with that?
Listen, it's a self-discipline thing. Firstly, have your bag with everything in it. That's the main thing. Make sure that you've got your DGS checklist. Make sure that you've got a copy of the load assessment form. Those should be part of your bag. I mean, it's like the doctor's bag. I mean, it's like, getting your heartbeat, taken by a doctor who's left a stethoscope at home. It doesn't really work. So it's similar too. And also make sure that your walkabout is very, very thorough, because by doing that, you're actually relating and drawing it down on your piece of paper. You're actually then relating your walkabout to your drawing, which makes it very difficult to then forget something. But if you have forgotten, there's no problem in phoning the guy up again and say, just remind me what's there. It's a teamwork approach. I mean, this thing can only work if both the customer, the client, and yourself are working close together and you're on the same page. If you're not, then forget it. Rather walk away from the job.
One more thing that interests me, the data collection, we heard that it has quite a big impact on the actual design of the PV system. So the better you get the load assessment and the site assessment, the more precise you can do your design afterwards, and the better the PV system will work out in the end. From your experience now, what can you say? How is your success rate? How precise were you when doing your site assessments?
I think it's always worthwhile, because you're always going to get the client that's going to say, well, a friend comes along and needs a hairdryer, okay, which is quite a big consumer of power. It's always worthwhile to size a little bit over, okay. In other words, always aim up rather than down. If you're trying to save money by being deliberately understating the load assessment, okay, or putting in less panels that are required, it's a false economy. It's a false economy. If this thing is going to be done properly, you're investing. The client is investing in a system that is going to last them 25 years. Why skimp? Honestly, and for the sake of another panel, or for the sake of upping on the load assessment and building a little bit, I'm not talking about doubling it or trebling it, anything like that, but just err on the side of caution rather than be too adventurous, because the adventurous approach is going to come back and bite you. And I think that's one of the reasons that we are successful, is because not one of our systems have failed. They've all worked bang on what we said that they should do. That's the way it operates. And I mean, the stuff that we've done in Montgomery, Heights. I don't know if you knew about that one, the orphanage. We put in a system at the orphanage. When I first went out there, they didn't want to know too much about solar. They were really conservative people. And they said, this using the sun to make power, no. We put a system in there simply to run their boreholes, because their boreholes was their biggest risk area, and they have 60, 70 children there. And if they ran out of water, it's quite a catastrophe, particularly when they're from birth going up to 18. So we started off with just looking at their boreholes. And now they're back to us all the time. Well, we want to do this, we want to do that, we want to do the next thing. And again, we're building it up in accordance with what their budget says. So yeah, to me, that's the way to go.
We had that on maintenance, that you have to, the smaller you design the system, the more likely it is to fail and not work. And then the client will call you, you have to drive out there, fix it, or I don't know, check the error, and it will cost you more in the end than you saved at the beginning.
Absolutely. In all of our installations that we've done, which are, and if I include JVS and Steve Harris, who I think you're talking to later, I don't think we've had a failure. We had one failure at Corunda, and that we believe was somebody playing some funny games and it blew an inverter. That's all. And the reason we know it was probably them is because they all went very quiet afterwards.
Okay, yeah. So that's probably a factor also to find out during site survey, how adventurous they are.
The other thing to do also, we would recommend, and that's based on experience, is actually insure the system. The client insures the system is a very positive way to do it. In case you get a failure, at least you're getting covered by insurance. And that's something that I don't think too many people recommend. But yeah, it's a good thing to do.
Definitely not for small systems, but like from 5 kilowatt upwards, I would say.
5 kilowatt upwards, I would certainly look at it.
What I'm taking away from this is really that PV system planning is not a precise calculation. It's lots of, you said that at the beginning, lots of checking and guessing and putting things together. But the better you do your homework at the beginning and the closer you look at the details when being on site, the better it turns out at the end.
Absolutely, without fail. Part of what we've actually had to do is actually go and attend to systems that have failed for the very reasons we've spoken about, which is actually quite a heartbreaking undertaking to do, because you see the look on the client's face when you say, well, this shouldn't have happened, and you've got to be careful how you say it, because you don't want to drop the other person right in it, for want of a better word, although they should be. And that's where the training comes in. That's where the training becomes so important, which is what we're all involved in some way or another. But it's really a key requirement to make sure that we look after our client, work well with them, make sure that your calculations are right. Double check, treble check. It's going to pay in the long run, by far. If you want the quick buck, get out of the business.
Yeah, definitely. We had that in an earlier podcast, that responsibility that you're taking the client's money, sometimes all of their money, just to give them power, and then it's your responsibility to make sure it works and they get what they paid for.
Fundamentally, absolutely true.
But I think I can summarize all you said into enjoy your work. Site survey is a very interesting part. It's not the installation, it's not like the thing everyone is keen on doing, climbing on the roof, but it's definitely in its way maybe even more enjoyable, because you get in touch with the people, you're doing kind of the groundwork for the later planning and for the later installation. So it is something where you need to bring enough attention on, and where you need to treat it carefully and execute precisely.
Yeah, it's the fun part. The rest of it is all sort of fairly boring. I mean, measuring out wire and crimping it and cutting it and all the rest of it. Everything goes in the same bloody hole at the end of the day. It's all fairly boring. This is the exciting part.
It's cool that you say that, because you've been in the business for so long. So after a while, if you can confirm the other stuff gets boring, but that's the cool part, then I think it encourages everyone to go on site visits.
Yeah, it's getting to the stage where if I have to go on the roof, I'm going to need a Zimmer frame to get there. So yeah, I'd rather concentrate downstairs.
Okay. Nice. Yeah. So thank you, Dave, for sharing your thoughts and your experience. It was really interesting, and yeah, I think it helped a lot to get an impression of how it is like to do site assessments. So yeah,